So let's go through a process of doing a natural language processing, a very simple example, but you will get to see how array can be useful in processing like this. So I have two documents. One is a simpler version of a Gettysburg Address. Another is the last paragraph from Lincoln's second inaugural address. I have already removed all the punctuations. There are still have some uppercase characters, and there are still like plurals, but that should be fine. We're going to parse the documents into array of words. Each document should have a token array. Then we will convert all words into lowercase. Then we will build a counting array and count words one at a time and calculate word frequency. So the first thing to do is to parse the document into an array of words and convert them into lowercase. Like here, 4 score and 7 years ago, the 4 becomes a lowercase f. Then we will build a counting array. Now the counting array comes up because there are duplications in each document. There's inevitably there will be duplications, right? The word "and," for example, I'm sure, or nation, or any nation. There are so many nations in this address. So what we are going to do is we are going to build an array of tokens which hold each unique word, and correspondingly, we will also have an array holding each word's count. This is called parallel array. You are creating 2 or 3 or even more arrays, which the elements in this array, if they have the same index, they are closely related. For example, if the first element if a token at 0 is nation, then counts 0 will be its term frequency in the document. How many times the word nation show up will show up in this counts. This is called parallel array. The length of the array is the length of the original array. Of course, we know that because there are duplications, so the tokens array will be shorter than the original array, but we just use this length of the original array so that just in case, though, in the worst case scenario that every word is unique, we will still not run out of array space. But of course, because this is going to be a partially filled array, we will come up with a counter. So now we will do a count of words one at a time. We will go through each word in the raw word array. We will find the word in the token array if we can find the word. So in the raw array versus the token array, if the word already exists in token, for example, if I already have a 4, then I will increment the count. If I don't have a 4, for example, 4 score and 7 years ago, I think the next word is our fathers. If our is here and is not existing the current token array, then we will add the word to the token array and set the corresponding count array to 1. For example, I will call our fathers. Then we will add 1, right? So by doing this, but then if I run into another word like and which is already existing, then I will change this to 2. I will add the increment. I will increment the count by 1. So, okay, so let me revert the change. And we will do this eventually. The result is such a array. Of course, this is not the real count. I just make up some numbers. So 4 score, 4 shows up 12 times, score shows up 1, and shows up 61 times. Apparently, this is the frequently used form. Then, based on this, And we already know how many words is there in total. We will get the frequency by dividing this count by the total amount of words. So you can also sort most frequently, usually we will sort the array with count descending so that the most frequent used words will come up first. Then we can see what's the most popular, most frequently used word of this author based on these two documents. And if you are able to go through all the poems and plays written by William Shakespeare, you will be able to get the frequency, term frequency of William Shakespeare. You can also break it down by poem versus play. Maybe he used this word more frequently in poems than he will use in plays. This is how you calculate word frequency. And once you have two authors' frequency of their document, of their whole collection, you can compare and contrast, and you can identify whether an article belongs to that person or not. So now that we have the frequency, one thing to note is, it's when we create the token array, usually it's recommended you create a token array for each document, and you will create an overall token. So for this reason, after that, you will create the total token, and you will have this matrix. You will define this correlation matrix of document frequency. The length will be the same as the total array, and all elements are initialized as 0. Then you will go through the total array, the token array for each document. For each element in the array, let's say I found 4. Then I will find the 4 position. Then I will look for other. Remember, this is for correlation. So you always need to find 2 words and find whether the word combination exists in this document or not. We already know 4 and score shows up together. And we can also see that 4 at the end shows up together. But there might be other words that does not show up, like charity. Charity shows up in the second inaugural address, but I think it's not in the Gettysburg Address. But let me search. I believe so. No, charity is not in Gettysburg Address, right? So the word combination of 4 and charity does not show up here. So find the position of 4, I, in the combined token array, which is 0. Then for all elements in the total token array, find its position J in the combined, for all elements in the documents token array, find its position. You find the J as score is 1. So 0, 1, and 1, 0, you should all increment it to 1. All right, and eventually you will have something like this for maybe 4 and 7 show up 2 times in 2 documents, and the 4 and the years shows up together in 2 documents, so on and so forth. So we will break up. This is a long lab, so we will break up the whole lab into multiple smaller parts, and so that you can finish that with some guidance.